Now let us see the deviation produced by refraction at a single surface. Suppose this surface separates two media 1 and 2, such that this is 1 and this has a refractive index mu. This is the normal. Suppose this is the angle of incidence I, the ray bends like this. So, it would have gone like this, but it has refracted like this. So, this is the initial direction of incidence, the ray was going like this. We define the deviation like this. This is the deviation. So, from the angle the refracted ray has turned from the initial direction will be called the angle of deviation. So, when it is I is 0, that means it is incident normally, then it comes out normally. So, then there is no deviation, but as you go on increasing I, the deviation increases. So, if I plot I versus deviation, initially for 0 value of I, normal incidence, there is no deviation, but as I go on increasing the value of I, the deviation also increases. Something non-linearly it increases like this. So, we will prove mathematically that deviation increases with increase in the angle of incidence. Now, suppose this is our surface, this is the normal, and we have taken a angle of incidence here. This is the reflected ray and this is our R. So, we define this angle, this deviation as I minus R. So, deviation is defined as I minus R. Now, in order to know that how deviation will depend on the angle of incidence, we have to use Snell's law. Using Snell's law, sin I, 1 into sin I, this medium is suppose 1 and here I have selected mu. The absolute refractive index is here 1 and here mu. So, 1 into sin I is mu into sin R. Refractive index of light in that medium into sine of the angle of incidence I is equal to mu sin R. So, simply I will write 1 sin I, that is sin I is equal to mu sin R. Let us just write. Now, sin I by sin R is equal to mu by 1. So, we will now use sin I minus sin R by sin I plus sin R is mu minus 1 by mu plus 1. By using componendo and dividendo, mathematical simplification we have done. Now, this sin I minus sin R is 2 cos I plus R by 2 sin I minus R by 2 by 2 sin I minus I plus R by 2 cos I minus R by 2 is equal to mu minus 1 by mu plus 1 we got. 2 cancels. This is tan, we got this is tan I minus R by 2 is equal to mu minus 1 by mu plus 1 tan I plus R by 2. So, we have to now study this equation. So, please take note of this. Now, you see here this tan of I minus R by 2 is the deviation. So, tan of deviation by 2 will be mu minus 1 by mu plus 1 tan of I plus R by 2. Now, let us study this function tan of I plus R by 2. You see I can be 0 and it can exceed maximum up to 90. So, when it is nearly 90, then the ray just grazes like this. So, this is also 90. That means, here I plus r by 2 is always less than pi, implies I plus r is less than pi by 2. Very important point. I plus r is less than pi by 2. Now, if I plus r is pi by 2, you see I am drawing the graph of angle theta and tan theta. How tan theta varies with theta? Suppose this is pi by 2. So, the function goes like this. That means, here pi by 2, tan pi by 2 becomes infinity. That means, the function is increasing. Here the function is, function tan theta function is increasing with theta. Now, here I plus r is suppose theta, this angle. So, if I increases, then will be r, and so will be I plus r. And thus, with increase in I, tan I plus r by 2 also increases. So, this function, so when I increases, this function increases. So, you see this deviation also increases. Thus deviation of the ray increases with the increase in angle of incidence. This is very important property, very important. The deviation increases with increase in I. Let us derive this result by, this is purely trigonometric method. By some geometrical method, let us derive this result. So, now let us see another method to derive at this result. This method is geometrical method and it was developed by P.G. Tate. This is purely geometrical method. So, the idea is that when a ray is incident, then it gets refracted here, and this is the deviation which is equal to I minus r. So, we have to study that deviation, how deviation will depend on I, where I is connected as sin I by sin r is equal to mu. So, when I and r is connected by this relation and deviation is equal to I minus r, so how deviation will depend on I? Let us study this. So, what we have to do? We construct a circle with center at O and this radius as A. Suppose this called, this is A and this is A. So, we construct a circle of radius A, the center at O and this A. Now, we join O at any point on its circumference. This is straight line to B. Now, we choose B such that OB is equal to mu A. OB is equal to mu A, where mu is the refractive index of this medium. Suppose this is 1 and this is medium mu. Now, draw an arbitrary line, draw a secant from B on the circle. So, we have taken this circle, we have drawn a secant AB, this is C and this is D. Now let us join these 2 points. Now let us represent this point as R and this point as I. So if this point is I, this becomes I. So we have now triangle. Now in triangle ODB, triangle ODB, in this triangle ODB, we apply sine rule. Sine of I by this distance is mu A, is equal to sine of R by this A. So we got here A cancel. So we implied sine I by sine R is equal to mu. So you see in this geometrical figure, this angle I and this R is related with sine I by sine R is equal to mu, which is my this relation. So if now let us see what is this angle. This angle will be called deviation because this is I minus R. So this is my deviation angle. So now you see here, when this angle R is increased, I will also increase, this I will also increase, and so will be the deviation. So you see, if I draw this line here, you see this angle R increases and you see this angle also increases. So you see this from geometry it is very well clear that with increase in R, this I also increases, this deviation also increases. Deviation will be maximum when this R has increased to this value, when R has increased to this value, and so this will be when tangent, then deviation will be maximum. So thus by this geometrical method we have proved that how deviation increases with R. So you see this R increases, so this angle has to increase.